The absent-minded professor. That's the image many of us have of a scientist hard at work in the lab. Well, there is some truth to it. Because of the technical nature of the work done here, it's pretty easy to become preoccupied with calculations and concentrations and forget about the basics of lab safety. We also tend to take what can be potentially dangerous pieces of lab equipment for granted as we use them over and over again. Now, if you're new to a lab, pay attention. What you're about to see are the do's and don'ts of laboratory safety. If you're already working in a lab or manage lab personnel, it's probably a good time to step back and review your work practices to make sure you're going by the book. We'll look at 5 major areas of laboratory safety: the handling and storage of chemicals, personal protective equipment, lab safety features, the equipment used in our water quality labs, and safe laboratory procedures. When it comes to chemicals, it's a good idea to treat every chemical you use as hazardous. Never inhale, ingest, or touch a chemical with your skin, and always keep chemicals separate from each other until you're ready to perform a lab procedure. Those are good general rules to remember, but you'll need to get much more specific when it comes to handling chemicals safely, and you can do that by first looking at the label. All chemical labels should be clearly marked with the chemical's name and hazards. Refer to the Material Safety Data Sheet, or MSDS, for more information on using and storing the chemical. There's a wealth of information here, everything from the protective equipment you should be wearing to first aid procedures and instructions on how to clean up a spill. This is also where you'll find just how much of the chemical you can be exposed to and still be safe. Permissible exposure limits, or PELs, are based on threshold limit values, or TLVs. That's the average amount of a chemical in the air you can be exposed to during an 8-hour work shift without suffering adverse health effects. The MSDS tells us what the chemical's flash point and lower and upper explosive limits are. Flash point is the lowest temperature at which a flammable liquid will give off enough vapor to ignite, and explosive limits tell us what chemical concentrations in air may explode if a spark is present. There's one other resource you'll want to keep at your fingertips: a chemical incompatibility chart. It lists the chemical on one side and other chemicals and materials you won't want to get near it on the other. That may seem like a lot of information for you to interpret, but you're not alone in this. A lab supervisor or lab safety coordinator should be designated in every lab. He or she is responsible for making sure not only that all of this information is available to you, but that you understand it and have the resources to work with these chemicals safely. So, that covers most of the primary chemicals that we'll use in the lab. But what about chemical reagents and solutions we make up in the laboratory? We need to make sure that we alert our fellow lab workers to the hazards they may pose. A reagent is a substance that takes part in or brings about a chemical reaction. Reagents made up in the lab should be clearly labeled with concentrations, the date they were made, and the technician's name who made them. This information should also be recorded in a reagent logbook. Now, this is another instance where the lab supervisor or lab safety coordinator gets involved. It's a good idea to have your supervisor take part in the labeling and record keeping of these chemical products. That way, information about the substance, including MSDS info, is made available to other lab technicians. The next area we'll look at is storing chemicals, and the key here is organization. Overloading and cramming a lot of different chemicals in the same area is just asking for trouble. Here are some of the things to keep in mind. Store lab chemicals in a cool, well-ventilated area out of the sunlight and protected from any ignition sources. Make sure they're in appropriate containers and that only compatible chemicals are in the same storage area. Special storage areas and procedures may be required for some chemicals, so check the MSDS. Some chemicals need to be locked up. Flammable and biohazard substances are on that list. Your lab safety coordinator may want you to maintain a log when a controlled or dangerous substance is moved in or out of the storage area. One final note on storage. If you're cleaning up or reorganizing the lab, never put any substance in the storage area that isn't clearly and properly labeled. If you don't know what it is, how will anyone else? Turn it over to your supervisor for disposal. Let's turn our attention now to laboratory personal protective equipment. If you're new to the lab, you're probably thinking, oh no, he's going to tell me I have to wear a lab coat. Well, someday you'll appreciate this lab coat. It's one piece of a body's worth of protection you need to work in the lab. It actually starts before you put the lab coat or jumpsuit on. Dress appropriately underneath. After all, this is your last line of defense, and anything covering up and protecting your skin will come in handy if there's an accident. Also, make sure long hair, jewelry, and loose clothing can't get in the way. Personal protective equipment, or PPE, needed to work in a lab may include leather, rubber, or plastic gloves, chemical aprons, leather or rubber chemical work boots, skid-resistant and chemical-resistant shoes, respirators, goggles, glasses, and face shields. There are a number of pieces of lab safety equipment to help you in the event of an accident or mishap. You need to be aware of the location and operation of first aid kits, fire extinguisher, and the chemical spill control kit. This equipment should be inventoried periodically to make sure everything is properly recharged and stocked. Emergency contact and medical treatment phone numbers should be posted at or on the phone. Everyone needs to be familiar with the operation of the emergency shower and eye wash sinks, and this equipment should be tested regularly. The MSDS for each chemical will specify flushing instructions, but generally speaking, for the shower, flush the exposed area extensively. Remove contaminated clothes while in the shower and continue to flush. Same thing for the eye wash fountain. Flush with your eyes open for at least 15 minutes. Talk to your lab safety coordinator about wearing contact lenses in the lab. Different labs have different rules. Some forbid it because of the danger of chemical gases and vapors being trapped under the lens and damaging the eye, or the problem contacts may create when flushing the eye in an emergency. Let's move on now to basic pieces of laboratory equipment. Water quality labs may be similar, but the equipment in them can vary or have very different operating instructions. It's your job as a lab technician to become familiar with all of the equipment used in your lab and be trained on any new pieces of equipment. Fume hoods are found in most labs and are used to prevent toxic or flammable vapors from entering the general laboratory. They are used as a protective barrier while allowing chemical reactions to take place. Safety precautions you should keep in mind when using a fume hood include making sure materials in the hood are kept to a minimum and are not blocking airflow or vents. When working with the hood partially open, make sure equipment and materials are pushed back away from the front edge to help the airflow and reduce the vapors coming out of the opening. For some chemical procedures, you'll need to make sure the hood is securely closed and all toxic gases are gone before reopening it. There are a number of pieces of lab equipment used for heating substances: autoclaves, controlled temperature hot plates, steam-heated ovens, even the old reliable Bunsen burner. The Bunsen burner is obviously providing an ignition source, so keep in mind a chemical's flash point and explosive limits. You'd be surprised how many people reach across an open flame to grab equipment or chemicals. So position your burner in a place where that won't be a problem. As for hot plates, autoclaves, and ovens, primarily you need to make sure you're aware of the hazards of working with hot materials. Make sure tongs, gloves, and other accessories are handy so you don't get burned. Don't forget, the heat generated by these types of equipment could also be an ignition source, so keep in mind flash points and explosive limits of nearby chemicals. Ovens and hot plates also fall under the category of laboratory electrical equipment. You need to follow some basic electrical safety precautions to avoid electrical shock and the buildup of static electricity. Make sure electrical appliances are properly grounded and not overloading laboratory circuits. Cords to lab equipment should have acid-proof and waterproof insulation, and it's a good idea to frequently inspect them to make sure they haven't frayed or come loose at connections. Make sure safety guards installed on any moving parts of a machine are in place and functioning correctly. Your lab should have a checklist that instructs you as to what pieces of electrical equipment should be left on overnight and what pieces should be shut off. We use a variety of compressed gases in the lab, but there are some safety rules that apply to all of them. Compressed gases should be stored according to local fire codes and manufacturer's recommendations, which usually means upright with a chain or clamp and in an area out of excessive sunlight and heat. Make sure the labels and hazard warnings on tanks are legible and accessible so you can make sure flammable gases and oxygen cylinders are kept separate. Most of the problems with tanks occur following damage to the valve, pressure relief device, and hand wheel. So never lift or carry a tank by grabbing these. Don't roll tanks on their ends. Always have a dolly or cylinder cart on hand for lab personnel and supply contractors to move them. The final bit of lab equipment we'll take a look at are the basic tools of every lab: beakers, tongs, pipettes. Equipment designed to help you avoid skin contact with chemicals that you're working with. These are pieces of equipment used to perform many of the everyday procedures in a water quality lab, which brings us to the discussion of how we can do that safely. Never use cracked or chipped glassware. If you do break glassware, immediately clean it up with protective gloves and put it in a container marked for broken glass only. It makes good sense to use plastic or metal containers and tools when possible. When carrying large glass beakers, use both hands, one supporting it from the bottom. When heating liquids in test tubes, remember that chemicals can be superheated and fly out of small containers, so always point them away from yourself and others. Wear gloves or use a towel when connecting rubber stoppers to glass tubing. Use a lubricant such as water glycerin or lubricating jelly to help make the connection, and be sure and clamp it. Always use the suction bulbs on pipettes. Never pipette with your mouth. Don't conduct hazardous procedures alone. If it's a small lab with limited personnel, use an alarm system and schedule safety checks by other water department employees throughout the work shift. Sometimes you'll need to continue a lab procedure while you're gone. For unattended operations, always leave the lights on with a sign on the door warning others about the hazards. Also, take into account the impact of a power surge or failure on the procedure you have scheduled. The proper disposal of chemicals in the lab is a very important consideration. You certainly can't afford to have a down-the-drain mentality about the job. In fact, the disposal of materials at the end of an experiment is as important as any other part of the procedure. It will take some research and planning. Consult the MSDS, label information, and your lab safety coordinator. Not only can some chemicals cause damage to the drains, create a hazard, or harm the environment, down-the-drain disposal may be illegal. Only water-soluble materials should be poured down a laboratory sink, and most chemicals need to be diluted. For example, you'll need to dilute acids and alkalis with large amounts of water. Always add the acid slowly to water, because water added to an acid container is more likely to create a violent reaction. Treat each chemical's disposal on a case-by-case basis, but always remember that sinks and disposal systems are interconnected. What is poured down one sink can emerge as a vapor in another. It's quite possible two different chemicals poured down two different sinks will come into contact. Your lab will have specified disposal procedures for many liquid and solid chemical wastes, such as labeling them and placing them in containers for pickup by waste disposal contractors. When you're done, be sure to wash all areas of exposed skin with antibacterial soap. It's a good idea to wash up whenever you enter or exit the lab, and following each lab procedure. And finally, here's one of the toughest safety procedures for lab technicians to follow: to leave that cup of coffee or soda can outside the lab door. That's right, no eating, drinking, smoking, or applying makeup in a lab. Simply put, don't bring any food or materials into a laboratory that aren't part of your work. There are some general housekeeping tips that also fall under safe lab procedures. Clean the lab area you're working in after each procedure and at the end of the day. Empty the trash and waste material often. Remove any tripping hazards and keep the lab floor clean and dry. Clean up even the smallest spills immediately. Discuss cleanup and waste disposal with the maintenance or janitorial service personnel, since the lab is unique from anywhere else in the building. It's been proven that clean labs also happen to be efficient labs. The better the work area and work practices, the better the data. And a note about microbiology labs. Housekeeping is especially important here because with a chemical spill, the danger is limited to what has been spilled. But if microbials contaminate a lab, they spread and grow. Since living organisms are being worked with, special care must be taken to avoid contamination of the lab, contamination of the samples, and exposure of lab technicians. In addition to the rules and standards of your company, your work in the lab falls under OSHA's Occupational Exposure to Hazardous Chemicals in Laboratories, commonly known as the Laboratory Standard. Employers are required to periodically measure your exposure to all substances regulated by the standard and notify you of the results of those tests. The laboratory standard specifies that employers are required to develop and maintain a written chemical hygiene plan. The plan includes work practices and policies that protect employees from hazardous chemicals. The plan designates programs for employee training and information, medical consultation and examinations, hazard identification, and the use of respirators and record keeping. It's a lot to keep track of, and it makes you wonder if an absent-minded professor can pull it off. Well, probably not, and that's the point. It takes a dedicated, serious effort to make any laboratory a safe environment. Don't let calculations and concentrations distract you. Think lab safety first, and continue to think about it until your work shift is done.